Good evening and welcome to the Six Figure Developer Channel. This is Live Coding Live Stream Wednesday, where we work on personal projects, stream our frustrations. Ash is a floating head. This is great stuff. We appreciate you tuning in. We do the live streaming, live coding thing every Wednesday, 8 p.m. Eastern. We do the live streaming of the podcast, 6 p.m. Eastern on Mondays. And next Tuesday, we'll be live streaming, hosting the stpete.net meetup.
Yeah.
So this week, we are working on Clayton's Blazor Game Engine, a port of Monogame. Although it's taken on a life of its own. Clayton, you want to catch us up and tell us where we are?
Yeah. So there are, let's call them inconsistencies in the way that Blazor functions and the way that Monogame wants to function. So I deleted all of that code and started over.
Excellent.
So I'll walk through what I now have, right, which is less than what I did have. I did keep my keyboard driver because that was mostly my creation, but it might change shape at some point. I'm not using it yet, so we'll find out. So I've created a game object interface, which has your typical game loop functions to update and draw. I did keep the stuff to import sounds and images and stuff because I liked the way that was working, although I will have to refactor it to get it to work in the new system that I have yet to design. Game Razor is now a base class that you inherit from, and it has the graphics context inside of it, so you don't have to... So before, you would wrap your game with a graphics context, and then it would the graphics context would kind of consume your game and run it. That's not happening anymore. Now you just have your game. So the graphics context takes a width and a height, which it gets from the game class itself. It has a default value 320 by 240. Good old super small, like Nintendo resolutions. For young people, a Nintendo was a device for playing games in the 80s. Super fun stuff. So then it has a cascading value of child content. This is where I intend to pass in the image registration and sound registration, stuff like that. I found... I think we talked some about this the last time that I streamed this, but I found the unmarshaled object, or the unmarshaled Java. Hello, Ash is just a floating head, but that's all the time. So,
Forgot to wear my spray-on, show that body.
Yeah.
Exactly.
The cardboard body that he normally tapes to his beard. So the unmarshaled JavaScript in Blazor is JavaScript that has direct access to the Blazor. So when you call something, it only works in Blazor WebAssembly. So when you call something, it's like calling it directly from JavaScript, not going through all of the wrapping layers that Blazor uses, which is kind of nice, neat. Fast is important. And then, so basically, when the component initializes or after it renders, then it's going to initialize the graphics context. And then it's going to start the loop, which is invoked from the JavaScript, which I'll show in just a moment. We update a special class I made to keep track of the frames per second. So we update it with the elapsed time. We call the update method on the game. We call the draw method on the game. And then we return if the game is not over. So basically we tell the JavaScript to keep doing what you're doing, everything's fine. If the game is over, then the JavaScript will stop rendering. So I guess you'll get stuck on whatever screen you were on whenever you told the game to quit, basically. And then there's virtual methods for update and draw. In the actual game class that you implement, and it does have to be a class, it can't be a Razor file. I tried making it a Razor file, but that wiped out the rendering from the parent class. So it's just a class. So you just make a class you inherit from game, and then basically you override update and draw and do whatever you need to do. Hey, Long Boolean, how's it going? In this case, I'm creating a new color. This is a class that I made. It's very similar to the monogame class, except I'm using float values instead of integer values. So all of the 255 stuff is now converted to a value between 0 and 1, because that is more compatible with what OpenGL needs on the front end, so, or on the JavaScript side. So when you render it, it tells you that, or sorry, when you create one, it tells you what values it was created with. That's just debug for right now. And I did add several constructor overrides. One of them allows us to do a hex code. So if you are using any old thing to pick a color, you can grab the hex code from that and paste it in here, and it'll generate that color correctly. Minus the alpha, it'll set the alpha to 1. So you'd have to get a little bit more creative if you wanted the alpha to be not 1. But if I get to that point, I might add another constructor that takes a longer hex code, or a hex code plus an alpha code, something. I don't know. Let's see. All right. So then in the JavaScript side, we register the game, and that is called, I think that's in the graphics context. When we initialize, register game. So when we initialize the graphics context, we're going to invoke an unmarshaled call to JavaScript. We're expecting an unmarshaled object reference back. So we're gonna execute a method in JavaScript, and we expect it to give us back an object. Because we called it unmarshaled, that object is an unmarshaled object reference. And then from that reference, we can treat it as a module where all of our code exists. And then we are invoking register game, and we're passing in the game, which was the parameter passed into the initialize. And then we are invoking initialize for the ID of the canvas that we're using, which is all part of the game initialization to create the canvas. Part of the graphics context initialization anyway. It has an ID up here, which is a new GUID to a string. The JavaScript passes us back an execute status, which consists of a is success Boolean value and an error message string value. So if it's not a success, then we show the error message, and if the initialization was a success, then we don't need this. Excuse me, we don't need this anymore, but I needed that before. Then we're just going to return the module, and that is in the game object, where it is calling initialize. It's receiving the module, and now if the game needs to, the game can call specific things in the JavaScript. I'm thinking that I might end up being able to remove this and have all of those kinds of calls go through the graphics context, but some of them may make sense to not go through the graphics context, and the graphics context might actually change to be some other kind of context, because the JavaScript is also where the audio and that kind of stuff is going to live. So I don't know. It will evolve.
Did you see Long Boolean's?
Oh yeah. Unmarshaled means hacky difficult stuff. Pretty much literally. 1 second, and I will give you a good example of what the unmarshaled means as far as differences. So if you look at register game, right? If you look at the graphics context, we are calling invoke. So invoke is just a normal. It's not asynchronous, but it's a normal Blazor JavaScript interrupt invoke. So you can pass objects in, and then you can just treat them, you can just receive them the way that they are, and everything's happy. right? And this is a .NET object reference so that we can call methods on this particular class, on the game class. Same thing when we invoke initialize. So if we go and we look at initialize, which is the next thing, you see that we just receive a canvas ID. Everything's happy, everything's good. We treat the canvas ID like a string, no problems. However, if we go to the graphics context and we look at clear, clear is an invoke unmarshaled, right? So it's going to pass in a color, and it's going to expect to receive an execute status. And we're just going to call clear, we're going to pass in the color. So that part looks generally the same, except unmarshaled. When we go to the JavaScript, that's where it all gets complicated. So we don't actually receive the values that we're after. We receive a memory address to the values that we are after. So we first have to use these special platform methods that Blazor provides. And so we read from the color address, from the address in memory, in JavaScript's memory, we are reading a structure, a struct, which if we look at color, color is a struct. And then once we've read in the struct, we don't get the values in the struct. We get the memory address that points to the values in the struct. And then we have to read the values in the order that they're defined in the struct. So we read red, which is a float field, and it is at the 0th position within that struct. A float is 4 bytes long, so to read the next float field, we have to jump ahead 4 bytes, and so on and so forth for each float. If we go and look at color, you can see that I have defined them here as RGBA, red, green, blue, alpha. So I have to read them in as red, green, blue, alpha. If I were to come up here and put alpha on top, all of the code would not function the way that you expect it to function. It would function badly. So then I have this GL, which got initialized here, where we initialize based on the canvas ID. And so we get the canvas, and then we get the WebGL2 graphics context from the canvas, and that gives us GL. And then as long as that all worked, then we're going to bind the render function to this particular object, and then we're going to request animation frame for the bound render function. Bind, if anybody's unfamiliar with it, is a way to lock a function to a particular scope within JavaScript. So we're locking render to the scope of this in JavaScript, and currently this is the scope of the game class, or this instance of this game class. So then that's going to get called whenever the canvas is ready. It's going to, or whenever the browser is ready, it's going to call render, which is going to render. It's going to receive a timestamp from the request animation frame. It's going to do some math with the timestamp so that we get a game time, like a total game time, or total game time. And then it's going to invoke on the C# class the loop method and pass in the current timestamp. And then it's just going to, once it's done with that, once that is finished, it's then going to bind render again. And this is a synchronous call here. So it'll wait for it to finish before it does this. And loop should not be asynchronous. It's just a synchronous call. All these are synchronous.
And so why are you having to do this extra?
Which extra?
Unmarshalling.
The unmarshaled? Yeah. So you remember several streams ago. Yes, Longwell, and the order needs to be right. We'll get to that one in just a second. I'm going to say cam. The reason for the unmarshaled is because it is way faster than the normal interaction between Blazor and JavaScript. It is a direct call as if the Blazor was in JavaScript. So you'll see, if you remember how before when we had the breakout game and we'd put like 50 things on the screen and it would all slow down? That doesn't happen now. So unless this blows up, because I did Control-Z some things to get the demo going. Hello. Huh. No, I've given up on that, Wesley. We're just gonna spend some time doing the next step, and it may or may not get done. So this is changing the entire color. I apologize for anybody who has epilepsy. This is changing the entire color of that whole canvas object 60 times a second, and I know it's 60 times a second. Oh, it's not showing. Okay, let's go. Did I change that to be false? But I think I did. So if we go to game demo, I told you I added that special FPS class. So if I say frames per second dot show FPS equals true, and then run it again, then we'll see our FPS in the console. $57, $60, $61, $60, so on and so forth. And it's only once per second. It's not like showing like, constantly. So that's good. So if I didn't do that particular call unmarshaled, then it would run a lot slower. We wouldn't be able to change the color quite as often as we're changing it.
Got it.
Well, that particular call we might be able to, but we wouldn't be able to do it for other calls further down the road.
Sure.
Okay, so ultimately we don't want it to be we don't want it to be a random color every frame. So that's why I made cornflower blue, and we can get rid of this. Oops, hello. Not all of that. We can get rid of the private color there, and we'll just why is that in? That doesn't need to be an update. That could just be in Constructor. And we'll just comment it out for now. We can turn it back on if we care to later.
You must be feeling better to go with the cornflower bowl instead of soul-sucking gray.
So a good portion of my game development attempts using some kind of framework or engine have been with Unity and with Monogame, and both of them start you off in kind of a blue. Well, I think Unity starts you off in like a black environment, but Monogame always, or XNA always started you off in a cornflower blue state. So cornflower blue is just kind of my default.
And Anonymous Cheerer, thanks for the bits. Appreciate that. And to celebrate, you might have got, I don't know, Ash, did you get a chance to mute, or did everyone get a chance to hear your
No, I did not get a chance to mute. Everyone heard.
I know I heard it.
The beautiful flush.
Yeah,
there it is. Oh.
Right, but it should be blue. Why is it not blue? See, it should be graphics clear, cornflower blue. Try it again, just in case something weird was going on. Because it didn't show an error. I don't like you. This was working like before, 5 minutes before we got on.
Oh, I understand entirely.
Clearing screen. We should see clearing screen a whole bunch. I don't know why we're not getting None of it's asynchronous, so we shouldn't have the issue where something happens and we just don't know about it.
Okay. Yeah. Definitely happening.
Okay. Clearing screen. Let me go back to not color here, and I had a console log red. Stop it. Green is next. I guess I need to leave some of these debug statements in just in case. But anyway, so the thing that I'm planning to work on tonight is adding shaders, which, since we're not doing anything on the screen, unless we add the shaders and then have the ability to get to something else, we won't actually see anything change yet. But I might be able to get to the next step, which is basically rendering a square on the screen. We'll find out shortly. Red, green, blue, alpha. I'm guessing right now that one of these colors is not correct for some reason.
Mm-hmm.
Even though they should be. Like, if my greatest hope is that alpha is just 0.
Yeah.
Because if it's not that, dang it.
1. Those look right.
Those do look right. GeoClear color bit, red, green, blue, alpha. And we saw colors a minute ago. We're not actually calling any of this stuff yet. So that shouldn't have anything to do with anything. Why is the screen not getting cleared? Oh, wait. Wait. I see. That shouldn't be that. That shouldn't be that at all. What?
Those should be like 1.
Yeah, what?
The value of 1, right?
Did I like accidentally Control Z something here? Okay, so this particular color is this one, and it's going to render this, which is going to come up here, float RGB. So we take the hex value, we shift it over 16, we AND it with 255. Oh, okay. Why? Well, then what, huh? This should actually be calling this, not this. Because this should be an int. Well, but then that just calls directly that, which is this one, which, yeah, why is this? I don't know why this isn't. That's stupid. Well, I missed it. What did somebody say? Alpha goes from 0. Yes. Yeah. So in OpenGL and WebGL, because of OpenGL, color values are float and they range from 0 to 1, as opposed to what you might be familiar with, where the color values are from 0 to 255. And for whatever reason, this is choosing the wrong value, even though it starts as a uint, so it should finish out as an int. I'll bet I had it as an int, and everything was good, and then I did a uint, and it changed it or something. But let's see what this does. There we go. Cornflower blue.
And that all worked.
Yeah, so this is Blazor, and this is JavaScript. And now we have the correct value. Okay, so that's all it was. It was just the casting got messed up somehow. Not a big deal. Okay. Right, so up here we have our shader program. Now these are WebGL 1.0 shader program instead of WebGL 2. So we'll have to modify these once we get them working. But I am literally just following the Mozilla WebGL stuff. So, in fact, if anybody wanted to follow along for some reason, there you go. So, I'm just trying to get their demo working, which renders a square. Is that in coordinate space or clip space? Renders it in clip space. So we will very soon want to go from clip space. So clip space is -1 to 1, or no, sorry, 0 to 1, and 0 to 1. 0 to 1 on the X, 0 to 1 on the Y, with 0 being the top left corner, 0, 0, and then going down to 1, 1 on the bottom right corner. We're going to want to change that over into whatever word I said a minute ago when I was still able to think. And then that will allow us to use our coordinate space. That'll allow us to use our pixel values as locations within the canvas. So we won't have to guess, between 0 and 1 where we want to be on the screen. We can just say, 20 pixels down and 30 pixels left or to the right. And that's where stuff will happen.
So does the origin still stays in the same spot?
Yes, the origin is the top left in OpenGL. Thank you, OpenGL.
It's just instead of going from 0 to 1, it goes from 0 to our max coordinate width.
Right. Yeah, 0 to our width and 0 to our height.
Got it.
All right, so the location that I was in this demo is I've got the Vertex Shader. Right, so the Vertex Shader applies a position to each vertex that is defined, and we'll define some vertices here shortly. So we'll get to that, and you'll be able to see what a vertex is, or vertex is. But right now, just this particular shader tells things where to be on the screen, and the fragment shader tells things what color to be on the screen. So the fragment shader runs for every pixel. The vertex shader runs for every vertex. So if you've got a square, then technically you have 6 vertices because everything is triangles. So you have 2 halves of the square divided diagonally down the center, and the bottom left, and top right are one triangle, and then the top right, and bottom left are the second triangle. And you have to go, I believe you have to go clockwise in order for them to render correctly. If you go counterclockwise, then the normals are flipped, which means that the what we'll call the front face of the triangle is facing away from the camera, which means that it's invisible because the back, well, once we turn on back face culling, which is something we'll do as an optimization, but for right now, we want to draw clockwise to make sure that everything is facing the camera. We're nowhere near doing any of that stuff. So, oh, is it the middle of the screen? That might be because of the way they're doing this projection matrix, model matrix, and this thing here, which I don't understand this yet. So, at the typical, like out of the box position should be the top left corner. But if that's what if you scroll down and read through, then you're probably right. I believe you. Okay, so Init Shader program is the next thing. So we've defined, if we look here, well, you guys can't see what I'm scrolling to. If we look here, I've got their fragment shader copied, basically. So they're just setting 1, 1, 1, 1, which means 1 on the red, 1 on the green, 1 on the blue, and 1 on the alpha. So everything is white. There's no colors that we can set. It's not asking for colors, nothing to do with colors at all. Everything is either white or black. And so the square will be white. We have cleared our screen to be blue, so that'll be blue, but the square will be white. And then, oh, dang it. I hate it when that happens. Okay, so then we've got their function here, which I'll refactor once I get it working, but I'm just going to type it in kind of as is to get it working. This will initialize a shader program, and a program consists of the vertex shader and the fragment shader compiled and put together. It is not, as I understand it, uncommon for a game engine or a graphics engine that is using OpenGL/WebGL to create shaders on the fly, like to piece together shaders on the fly and compile them into programs and then use them for whatever's on the screen. I haven't gotten that far, so I haven't seen that in action, but at some point this might all get very complicated because it's not already complicated enough. All right, so I'm going to move this back over, and then I'm basically going to copy this function from here to here. And that will be right here. So Vertex, and I know I could copy paste, but I don't know. It gets jammed into my head better if I type it all. So fragment shader. Yeah, jeez. Fragment shader, and then this dot fragment shader 2D. I do have slightly different names than they have as well, so there's that. Okay, so create the shader program. Now, I'm going to try to just get this working, but then this whole shader program that gets returned is probably going to be stuck into some kind of buffer so that we can reference it easily within the game. Some kind of like a shader program array or something that'll have a so like we'll make like a simple object that has 2D shader or 2D and then as like a name value, and then the program as the value for that 2D shader. Right, no, not panner. Program.
So how's everyone doing today? Pretty good?
I'm doing all right. Got some good news, but we're not going to talk too much about it here. But I had a good day.
Blazor Mr. Magoo is here dropping. Welcome.
Drop Ed. Then,
He
how's it going,
dropped
Mr.
a
Magoo?
Smiley face with sunglasses.
Did I hear right that you are also working on a Blazor Game Engine? Yours is probably much further along since I just deleted all of mine. Yeah. status. We're not going to alert. We're going to throw. Can you throw in? You can throw in. Sure. What's up? Huh. I guess I kind of know that feeling. Usually when mine is sort of starting to work, I just delete it and start over. That's what happens over here. GL dot get program info log. What technologies were you using for yours? Were you doing Canvas or divs, or what were you doing? I don't even know if that works, but we'll find out. Return shader program. Okay, so we have that. Load, is it this load shader? Oh, well, I don't have it defined yet, so it doesn't really matter. Yeah. There we go. Okay, and then load shader is here. So it takes a throw up. Yeah, I guess. Yeah, sure. Blazor, HTML, and CSS only. Okay, so it's like a div and CSS based game engine. I've seen I think 1 or 2 examples of people playing games that were written that way, but I haven't seen what the actual code looks like the the way that it renders it all out. Load shader. Okay, so GL, not GL. We don't need that. It's part of the object. We don't need to pass it in. Type and source. Shader. Type. Hey, now. Come on. It's a header. Shader. Why do I type better when I'm not looking at what I'm typing? Yeah, I type so much better when I'm not looking. Yeah, well, it's over that. Compile.
I'm with you, Code. I'm with you, Sean.
I missed it. What happened?
Code with Sean. Code's better when he's not coding.
All right, and then I guess we'll just throw again here if that goes wrong. It's weird. I've never done it like this. I feel like I should make like a function that generates the error message with a false success, and then I don't have to keep typing all this over and over again.
Oh, yeah.
Why? Don't autocorrect when I'm doing it right. Stop it.
Would be a good spot for refactoring, right?
Yes. Once we get a white square on the screen, then I will look at refactoring. There we go. Yep. Otherwise, return the shader. Okay, so that's that. I'm going to move this up above. I don't like that it's being referenced from... Not in JavaScript, anyway. Things that are being referenced should be reference up. Okay, so...
Unfortunately.
Yeah. I mean, it's a class, so it doesn't have to be that way. I could put it below. It's just, I don't know.
Sure.
It's JavaScript, so why not? So it's going to create... That should create the program. Excuse me. That should create the program for the 2D shader that will do the rendering here. Okay, and then they wrap that into... Yes, okay. So we need something that will initialize the shader. Do I call that with... I feel like I want to, but then we'd have to have these get attribute stuff in the Blazor as well. For now, I'm not going to... I'll make like a function that is create shader, and it'll do this part. So cost shader program equals init shader program, vertex shader, and source. So wait. So vertex source and fragment source instead of this part here. There we go. And then here's where we would say this dot vertex 2D and this dot fragment 2D. Okay, so that's going to give us the program. And then we're going to take the program and we're going to stick it into this object. And I think as soon as this is working, we're going to do those simple refactors that we were just talking about, such as pulling out this error message to be a function that generates the error message. And then I'm going to try to push some of these things up into the C#, like the maybe the shaders and the this program info object. Program shader program. Now, for some of it, like the shader program, it's probably not going to be something we can directly reference, but we'll get like I assume we'll get like some kind of memory address, and then we pass that down, we'll be able to use the memory address, but I don't know. The actual important part that we would need the C# to be able to do, because if the C# is going to generate these, if it's going to generate these shaders on the fly at some point in the future, it needs to be able to define these attribute locations and uniform locations. Because the JavaScript's not going to be able to do that because it has no idea what the C# is trying to actually accomplish.
Got it.
So I'll have to make a helper method to actually call this get attribute location thing, and then pass the location back to the C#. Get attrib, yeah, location. Position. comma. Why are you way over there? Uniform locations. All right. Is there any more questions? Nope. Everybody's either amazed at my awesome ability to code or sleeping. Let's see. Projection matrix. Now I think that, unfortunately, this thing is going to have us do calculations based on a. Maybe not. Maybe not yet. And we'll show the code here in a second, but I was afraid it was going to have us do calculations based off of a third-party matrix library, which I will not be using, because if you're going to do it the hard way.
That's the Clayton way.
Yeah, at least in my side projects. I keep telling people that that's only for my side projects, and at work I try to do it the easier way. Sometimes that's true. Sometimes I run aground, but projection matrix. So for anybody looking at the code that I'm writing here, these are direct reference to the code that we had in the shaders. So you can see there is an attribute location that's a vector 4. So it has a X, Y, Z, and W value. And it has a vertex position is the name of the variable. And then we have uniform locations, which are matrix 4. I believe that's a 4x4 matrix. And then we've named them U model view matrix and U projection matrix, because we're using Hungarian notation with the A's and the U's and the stuff and things. Those can be named anything. I don't have to stick to that naming convention. I just am, because that's what's in the demo code that I'm processing.
Get that working first.
Right. So this would be model view matrix. And then later we'll have a model view model matrix. Always fun.
Probably eventually.
Model view matrix. And what project are you working on today, John?
I'm not telling. I am working on getting Sonarcube set up for Speaker Meet. The UI pipeline. Now, I got the API pipeline going last night and invited Ash to that, because Ash and I are going to put together a demonstration for DevOps Day for an organization. So, trying to use Speaker Meet for more training and demo purposes.
Nice. All right, so we've got the create shader function going, and so right now all they've done is create the shader program, capture the program info, and then they jump down here into this creating the square plane. So I don't know exactly what's going on, but this is going to be our next function. We'll make an Init Buffers call, and then I'm probably just going to hack this into the C#, calling the methods that they have with no real point to them, and not really consider the graphics library or graphics engine portion of it. I'm just trying to get the demo working. Okay, so Init Buffers. Okay. Okay, so we created a buffer. To apply buffer. Yeah, so apparently OpenGL is all about supplying data to the Vertex Shader and the Fragment Shader. So all we're doing with this really is just creating a set of data to pass to those two programs. Or to pass to the program consisting of those two shaders. And in this case, we created a generic buffer so we can stick stuff into it. And this next command here, which is bind buffer, is where we're telling the buffer, or where we're assigning the memory address of the buffer that we just received to OpenGL. Blazor, Mr. Magoo, I am really hoping that that we will get back to the bouncing ball game soonish. Honestly, to go from rendering a square to rendering that application is not that far of a leap. And because I don't know any better way to do it, I'm sure we will get the random the ball movement again, and I'll have to troubleshoot it and figure out what's going on. Bind buffer this dot gl dot array buffer, so it's going to be an array buffer, and it'll be an array of floats, and we're just saying that we're going to use the position buffer for that purpose. And here's the part that annoys me with all of these demos. There's no separation of what it is that you're doing, when, and why. So we've created a buffer, and now we're just going to create the positions for the buffer. So it's not like create a buffer, and then another function assigns something to that buffer so that we can like draw a square, or so. There's no draw square function that they have in their demo. And it's difficult sometimes to know where the break is, like where we leave from setup code and go to actual data that for what what it is you're trying to do code. But
yeah, because this is what's defining that square.
Right,
so
now we
like
have positions equals, and that's going to be an array, and this is where we're actually defining, the square. But it's a function called Init Buffers, which is not draw square or define square or anything like that. It's init, but just get the buffer ready. Like, switch over to that buffer and then let us populate that buffer. Now this position buffer that we have here, like, it's just a memory address, right? So we could put anything we want to in that memory address. And here we're saying bind that memory address to the array buffer. WebGL has several different kinds of buffers that you can use. So there's really no reason that I know of to do this here. What we're going to want to do eventually is take this position buffer and actually make it something within our global namespace of our class, so that we can reference it at any point that we want to. But none of the demos do that, though. They'll break out functions for creating the shader, but then when they actually want to draw something on the screen, it's just like blah. I don't know what the deal is. Okay, so like I said before, though, we need so I also don't know how this function works, how this demo works, because you remember if I said earlier that everything is triangles, right?
Yep.
So in order to have a triangle, you need 3 points. And in order to have a square, you need 2 triangles.
Yep.
Well, they don't define 2 triangles. They define 4 points.
Does it... Okay. I wonder if it just works that out for you.
It does in their demo. We'll find out if it does for me, but I doubt it.
So long Boolean, some of the behavior, on the minor side was when we bounced, we would randomly change the speed of the ball, so that was fun. But the really odd stuff was when we would bounce into the blocks and then accelerate through them. That was the super fun stuff.
Okay, so Cam is saying that it's something to do with element buffers, and that the element buffer would do what it appears like they're doing with this array buffer.
I see.
I honestly have no idea, but I just barely read anything about element buffers so far, and oh my word, their draw scene is. I think they do. Yeah, they use the matrix stuff here. They got a mat 4 dot perspective, yada yada stuff and things. So I don't know. We may or may not get anywhere. Okay, so now pass. Oh, Cam went warp speed on me. They're using triangle strip instead, which automatically zigzags through a list of points, making triangles 1, 2, 3, 2, 3, 4, 3, 4, 5, and are they? So they're drawing like a lot of triangles. Long Boolean. I suspect if you change the speed on hit, then if you push off with that new speed, there could be cases. Oh yeah, the long Boolean, you talking about the breakout game with the ball acting funny? In this case, just the 2. Okay, well, we'll see. I have tried to replicate this demo before, and I did not get a square. But I would then use it to fill. But I was also trying to make sense of all of it, so I was breaking out functions and stuff, and I'm gonna try not to do that this time. Static draw. Okay, and then they have this returning the position buffer. Yeah, position buffer. Okay. All right, yeah, our create shader is probably actually going to be draw scene, because they've got in this next section, they've got a draw scene here. And their draw scene does the color, and it even sets some extra stuff that we're not setting. And then, so we might add these to our clear. And then it sets up a whole bunch of stuff, and then mat4 translate, num components, bind buffer, vertex attrib, enable vertex attrib, use program info program. Okay, no, so this other stuff is still getting set up ahead of time. Interesting. Okay, so fine. Create shader. That's fine. Whatever. So I guess we can return the program info, and it doesn't necessarily need a name at that point. And then we'll init buffers, and we can do all of that in the initialize sometime after we have GL. So we'll say this dot program info equals this create shader, and then this dot. Was there something returned from init buffers? Yeah, position. So I'll just say this dot buffers equals this dot init buffers. Do that. Or well, hold on. I assume. Where'd it go? We don't need to do that yet. There's no fancy stuff going on. Okay, and then that's gonna be separate. Okay.
Good night, Blazor, Mr. Magoo. Thanks for stopping by. Appreciate it.
Yep. Good night. Have a good one. Okay, so yeah, so we've got that, and that gives us those, and then we'll have the draw scene, which is the next. Where did my thing go? I didn't close it, did I? No. Okay, there we go. All right, so I'm gonna oi this.
Yes.
Except for I'll start pretty much here because we're already doing this part.
Yeah.
Although I probably want to add these two to my clear. Because we are not doing those. So clear color. Oh, well, those three actually. Clear depth as well. So clear color. I'll still wrap it because this is stuff that I'm not sure about. Clear depth 1.0. And that may be a value that we end up needing to pass in at some point. This .gl dot this dot enable. Depth test. And at some point we'll also have to do the thing that enables whatever it was that we had to enable something to get the PNG transparency. Would it blend or whatever that was?
Oh yeah.
Depth function is dot equal equals inferior sibling. Whoop. There we go. And we don't need that. Everything should be good now. Okay. Yes. So we have that. Right, and then okay, so it's actually this changes. So it's color bit binary or depth buffer bit. So when we set fancy depth things. All right, so now we go down to draw scene, which is something we'll just be calling. Field of view is 45 times math.pi divided by 180. You know, because.
Yeah.
And that's in radians for anybody who didn't know. Aspect equals this dot gl dot.
I think that's why you divide by.
I'm really glad you cleared that up for us, though.
Dot canvas dot client height 0.1. I'm just copying these values straight from this thing. I don't know what any of them mean. Bum, bum, bum. Sadness. All right. To move things along, I will import
Do it.
this matrix library.
Do it. Ship it.
Do it.
And then I will promptly unimport it as soon as we do a refactoring to where it's like our only dependency, like before moving on to the next whatever. Is there a...
You're also using math there.
math is built in. I'm not going to reinvent pi.
Why not?
They're using a CDN reference, so I just need to open this here. See, so it works for them. I don't... We'll see. Elements, head. There it is, right there. So we'll just copy outer HTML, and then we'll go to... Oh, you guys couldn't see any of that. That's fine. We're going to go over here, and we're going to say, yeah, that, because I don't know why. And then the matrix 4 thing should work just fine. Well, I mean, it'll complain, but...
So do I.
It's never stopped anybody. Okay. Yeah, so then...
Just in case anybody was curious, I got Speaker Meet UI up in Sonarcube now.
And what is Sonarcube?
Well, I'm glad you asked, Clayton. It is a static code analysis analyzer. So let me paste that in the chat. You can bring it up and take a look. I'll put that in over here as well.
Ooh.
Projection matrix.
You've got some bugs in your UI. Or bug.
Those are
actually
undocumented features.
It's actually in the CSS, and I am absolutely sure that I copy and pasted that from somewhere and have no idea what it does. It's a media query in CSS, and the parameter is prefers reduced motion equals no preference. I have no idea what that means.
I wasn't listening, so neither do I.
Good.
Sure, I'm sure it's fine.
You know what'd be kind of fun? I don't know how we would do this because I don't know how in the world we would share two screens at the same time. But there is a CSS battle that you can do where they give you a picture and they're like, recreate this in CSS. Those things are fun to go through. That's not CSS.
That's me waving the white flag that I give up on that battle at the very beginning.
Have more faith in yourself.
I know what some of my strong suits are. I also know what some of my not strong suits are.
I mean, I wouldn't say that I'm like... I don't even know that I would even say I'm good at CSS, but I do think it's fun to play around with the different things and learn new ways to accomplish stuffs. Then again, I'm doing this, so...
Right. It's fun until it's not, and then it's so incredibly frustrating because I just haven't spent enough time with it.
Well, I mean, that's why you do this kind of stuff, though. And then somebody can be like, hey, I was using this projection matrix in my CSS transform, and I don't understand what it's doing. You'd be like, oh, I was doing that in WebGL the other day. It's not a thing at all. Here, watch this.
I'm sure this will come up.
It really won't.
Ow. don't know. It might.
I mean, now that I've shared the Sonar or the Sonarcube link, and somebody's going to point it out. Hey, what's that?
I don't know. Leave me alone. Why is everybody picking on me?
It has some very
Destination.
spicy C# too.
I have what?
It's got some good code odors. 16 of
smells.
them.
Yep. And some of them, like, I legit leave there because of the...
Couldn't be bothered.
Because it's an exercise for people to learn and grow. And so there are things that are legit not implemented. And so they throw a not implemented exception because I want people, as we're showing this,
Got it.
hey, implement that.
Is that what those are?
No, those are actual mistakes. That's
It looks like it's on the post for speakers, and it's on the post to put and the delete for the three types. It's actually not throwing not implemented exception. It's actually just an empty method.
Oh,
Because I don't want that anonymously available. 2, I don't want to have to worry about how to secure that. And D, for reasons 1 and 2.
skip 3.
For
skip
A and
3
2.
altogether, but okay.
I'm glad everybody was paying attention.
1, 2, and D.
Yes. No, it was A, 2, and D.
Yes.
Oh, okay.
You gotta keep up.
Hey, Professor Void just rated the channel with 4 viewers. Welcome, Raiders. We'll wait. I'm not sure if we have ads playing at the beginning, so we'll wait a few minutes and welcome them again once everybody's in and settled. Appreciate the raid. What were you working on? What were you doing tonight, today, whatever time it is in your neck of the woods?
They couldn't hear you. They're watching an ad.
Long Boolean, it was absolutely an excuse, and I think it was a good one. So Clayton, is your stuff checked in? Your destroy it and start over again, or
It's in a branch called WebGL-reboot. I will make sure that it is pushed all the way up at the end of the night. I'm not sure how far it's pushed up. I'm not sure if I've got the changes that we started with pushed up.
Hold on, I think it is story time. Professor Void just finished teaching their students about bears.
And beats? Or and Battlestar Collector, or just bears?
I'm so confused.
That's an overloaded term. It could mean a lot of things. You talking like Teddy Ruxpin?
Like my neighbor. So we walk our children to school because we live walking distance to school, and everybody's back in person now. He's got a cabin in the woods, and he's got a security camera set up. And he said his daughter and her fiance took their trailer or like camper or something and left it at the cabin, and a bear came by and they got it on video, and the bear was checking out the thing. So I mean, bears are a thing even in Florida. They're a lot smaller here.
Where did buffers come from?
Buffers are
important.
important.
It got passed in. But
So surely the ads are done if there were any. So welcome, Raiders. Appreciate you coming and hanging out, learning about bears. I'm so very confused. I'm gonna have to go back and hopefully the stream is still there with the replay. We can go back and watch it and learn about bears as well.
This time buffers don't.
This is the Six Figure Developer channel. It is Live Coding Live Wednesday, where we work on personal projects. Every Wednesday, 8 p.m. Eastern. Sometimes Ash is a floating head. Sometimes he wears a different shirt. Otherwise, we'll be on camera working on whatever project suits us at the moment. This evening, we're working on Clayton's Blazor Game Engine, a port of Monogame, or what started as a port of Monogame in Blazor. He has now scrapped it and started over. He's on his third iteration this time, I think.
As you do. Well, no. So this is the first. Well, okay. So third or fourth iteration overall, but it's the first iteration where I've said I'm going to have too much trouble adhering to monogame, so I'm just going to throw the monogame thing out the window and start fresh. So it is now a unique and individual game engine that is not intentionally mirroring any other game engine. Now, I might borrow parts from here and there that I've seen that I liked, but I'm not directly trying to copy or mimic anybody else. I forgot what I was doing. Oh, a trib location.
And right now, you've been trying to wire up shaders, right?
Yes, by copying the Mozilla WebGL demos. Thanks for making me a liar right out of the gate.
And if you enjoy this kind of banter, we also live stream the podcast at 6 p.m. Eastern every Monday. So we would certainly love to have you click like, subscribe, do all the things.
Yeah, so basically I don't actually know how to do OpenGL or WebGL for that matter. And so I am learning it as we're building the game engine by looking at several different resources. The first resource, the one that I'm using tonight, is the Mozilla documentation, the MDN. And they have a WebGL tutorial, which I'm kind of running through right now at the very beginning of it. We're just trying to render a white square in the center of the screen following their demo, and then we'll refactor it and try to break out the important bits, which are deviously difficult. Excuse me. Deviously difficult to separate, just because none of the demos actually tell you what parts are set up and what parts are actually doing the thing that is the object of the demo. And maybe that's just the way that OpenGL or WebGL goes, but I'd have to think that since there's game engines, that can't possibly be right. Programinfo.trib locations, vertex position. Okay, so that's the end of the... I don't know why I have this block scope in the middle of nowhere in this function, but they do. Okay, that must have been from before. Yeah, so I'm just following. Here is... Yeah, that's what I was just reading. Yep. That actually sounds kind of interesting. I like learning new random things.
Spend time with researching with viewers to discover cool and interesting stuff about specific subjects. This week was bears. Is there something that can be easily added to chat that you can learn us, or I am going to go back and watch the stream because
bears have 6 legs. What?
That's
all I know.
That would be interesting. It's not true, but
you don't know that.
That's how fast you have to run.
Are you a bear expert?
I have to run faster than one person. Yes, is as fast as I need to run.
Whoever you're with. And you've got a kid, so you don't really have to run that fast.
That's right. You just throw the kid.
I'm gonna make sure the kid survives. So if I need to trip somebody, I'll trip somebody.
So the wife is going down.
She did threaten to throw me into traffic the entire walk home this morning after dropping the kid off. So I'm not gonna say that I would trip her for the bear, but I'm also not gonna say that she wouldn't trip me.
So all's fair in bears and the woods.
No, I'm just saying
this is why we have redundancy, though.
I'm going to say that if I get killed by a bear, you know that the wife tripped me.
Uniform matrix 4 FV. I don't know what the FV is for, but
Isn't that one? Wasn't that the 4-vector or 4?
Applications.
Isn't that referencing something earlier on? But
Yeah,
anyways.
I don't know. Floating point vector? I don't.
Floating point, yeah, maybe.
Or vertices? I don't know. Yeah, so Cam thinks it's the same thing. I saw Pizzly. I thought pizza and what?
That's exactly what I was thinking. But turns out there is a bear hybrid that exists called a Pizzly, which is a polar bear and grizzly mixed. They've been discovered in the wild and in zoos. Interesting.
Good times.
That sounds kind of
Well,
terrifying, actually.
They're
Yeah,
I don't know how long ago this happened, but
and angrier.
yeah, I don't know how long ago this happened, but didn't the I think it was the grizzly or one of those bears up north, but the polar bear is literally just like effectively like an albino offshoot of that bear. Like they're not their differences are very minor.
Well, but they're not albinos because they have black noses.
Right.
And one bear fact that I think
A snow-colored variant.
Yeah, one bear fact that I think I learned, which may or may not be true, is that when bears are hunting seals, like there are holes in the ice for them to come up, that they'll cover their nose so that they're all white. I don't know if it's true, but I heard it and it sounded great. So I'm going with it.
Or it's because they think the seals smell.
But where do they keep their stash of Coca-Cola? That's what I want to know.
In the icebox.
Okay, fair
Obviously.
This.gl. Uniform matrix FV again. Oh, not that one. Unwatch. There we go. Cam, any idea what this is doing? Because I don't. Uniform locations, and this would be the other one, yeah, model view matrix. False again, whatever false is. Model view matrix. And this is the only demo that I've seen that's like this, where it's doing the matrices transformations. Vertex coconut. Nope. Draw arrays. See, we're drawing arrays instead of elements or whatever, which is what confuses me with this.
Oh, is this the triangle strip that Cam was talking about?
Yeah, and
it must be taking that vertex count to know how many triangles it needs to make out of that position array or something.
Sorry, I was reading about ligers. What? What did you just say?
I was just saying that. So he was saying that the triangle strip was just sort of bouncing back and forth between those, and we're saying, okay, so we had originally had that buffer of positions, right? But you're now defining that you need to have 4 vertices, so you're telling that triangle strip to say take this buffer, turn it into 4 vertices.
Right, something
and
like that.
It'll turn triangles out of each one of those indices.
So okay, so we've got that's the end of the code that they have for their demo, and then they're just like, ta-da! See, it works. So I have changed as little as possible with this code, but we still need to call it from the Java or from the C#. So up here, we're getting the module. So we should have access to the module. It should be a protected. Where is it? No, it's private. Protected. For right now. We might change that later, but protected for now. And then I can go into the game demo, and I should be able to say module dot invoke unmarshaled, and we're expecting object back. We don't actually care. And then we're going to call draw scene, I believe. Let me double check in the thing here. Yeah, we're not calling it as if it's namespaced. We're just calling it directly because we have a direct object reference to the JavaScript class that was created. So maybe this will do something. Let's see if we get any errors. Yay!
Oh yeah, we got some errors.
Okay, so init shader program is not defined. I'm guessing I forgot to do this. So that's going to be up at the top somewhere. Initialize. Create shader. No. Stop it. This one. Yes, I need to do this. .init shader program. Save, and we might be able to just refresh and see what happens. Okay, cool. We get a different error. Game Razor line 31. I don't know. Graphics context line 28. Okay, invoke, initialize. Oh, no, we've called this before. Network. Yeah, let me just refresh one more time.
Yeah.
Nope. Okay. We're not even getting as far as we normally get, so I'm just going to stop it. I'm going to restart it and see what happens. Okay, so it is failing. It's failing in the JavaScript. So yeah, JS exception undefined. Okay, so we need to go look at this, and that's in the initialize function. So we're saying this program info equals this create shader, this buffers equals this .init buffers, and then the rest is not affected. So one of those is causing the problem. I'll do this, and we should see an error at a different location. Yeah, so this time we got probably a similar exception, but we got it at line 204 in the JavaScript at draw scene. So that's good. Now let's bring this one in and save and refresh, and I expect, okay, we're getting it in there somewhere. So it's in create shader. Program, shader program, attrib locations, this.gl.get. Okay. So I'm going to comment this out and comment that out and save. And we'll just kind of walk it back until we get to the point where we're seeing the undefined cannot read property position of undefined. That's fine, because that's no. Well, it's one of these things. It's at one of these. Okay, that's fine. Okay, if we bring this in, do we get that error? We do. Okay, so it's not this stuff. it's going to be in here.
Yep.
I'm not seeing anything super obvious. Okay, so let's comment out.
This one is slightly different, right?
What do you mean? Well, it's just going to return undefined. It's fine.
Oh, in that you're not passing in GL because GL.
Yeah,
this is inside of GL.
Right. Yeah. The only thing that's different is that. Oh, hey, look, there it is, right there. That was it. Yeah. The GL is not being passed in because it's part of the class.
Right.
So there was no reason to pass it in. Oh, that's
yeah. So that's what I was making sure is that references to GL we had to then.
Pooh. Okay, well that was one of them, but apparently not the only one. Okay, let's
I imagine it's something similar.
this GL, this GL, this GL, this GL, this GL, this GL. Okay, let's see. Let's see if we can get past those without blowing up. I mean, if it's not happening up here, it shouldn't be happening here. I don't know why it would. This GL, this GL, this GL. Yeah. Let's see what happens with this.
Is it possible that we could have gone beyond this now? Or is it still...
Yeah, no. Because if I comment in... down here. No. Where is it? If I comment in this line, then I would get the undefined error. And then if I comment in this line, we get the undefined error. Like if I could just do this probably, and
got it.
It would still be the same. And we do have. Oh, hold on. Yeah, undefined, just random JavaScript exception from somewhere. So that makes me think that it is somewhere up here. So if we comment this out and save and then refresh, then we should see like an issue in the JavaScript that we can trace like this, right? So if we comment that back in and refresh, then we get that. Okay, so it's saying that one of these it is not happy with. So if we look at load shader, GL Vertex Shader, Vertex Shader, okay, fine. Vertex source is coming from Init Shader program, which is create shader, Init Shader program, this Vertex Shader 2D, Vertex Shader 2D, which is this. Now I can drag this up here maybe and save and see if that has any effect. But it doesn't, and it's saying undefined.
Thank you for the follow, PH477Y.
But it's just execute status, invoke execute status. Okay. So anyway, so load shader, and then we're getting an error if we run this line. So let's see what happens. Ah, look at that. Yeah. Okay. Mm-hmm. Yep.
What are we seeing?
Yeah, you definitely don't want 356.33. I mean,
Right.
that's
So if we go back up to where load shader is coming from, and it is saying that, well, no, maybe we do, because that's coming straight from the GL object. It's coming straight from the thing, and it is vertex component. That's the only thing that we're passing in here. Load shader is being called. We're calling it this. Load shader. Init shader is being called, and we're passing in. Well, it's getting to that point, so it's got to be. I don't know what. I don't know what it's griping about. Everything's being called from this, so it should retain the this. Like, this shouldn't be anything weird.
Okay, I'm saying try catch.
Oh, well, yeah, no, shouldn't. Okay, so this, right? And then we go to the loader, which is up here. What's the try catch? What do you, you think maybe that's a problem? Because it could, I mean, it could be. Well, and I'm not catching it anywhere. You might, yeah. Yeah, it could be. Okay. Let's change all of this stuff to alert, and we'll just alert that same error message. Get in there, and then return null. And we'll just do the same thing down here as well. Did I do that pattern anywhere else? It's possible that pattern doesn't work at all. I was just trying something. Okay, do I have things here? Let's just comment things back in, because if it is that try catch, then we don't really want to. We don't really want to not run any code. Okay, let's try it again. Make sure that that is, yep, good. An error occurred compiling the shader error U model matrix undeclared identifier. So spelling matters. So we've got U model view matrix, and then here we got U model matrix. Yep. What was when you move from WASM to JavaScript, that entry point, just jump in there and wrap the inside of your function with a try around everything and then print anyway. Oh, yeah. Boom, but at least it's a valid boom this time. Okay, 209 is now the culprit. 209. this.buffers.position. Buffers should have a value. Oh, no, I'm not running it because we were isolating. Here we go. There we go. I'll fix that right up. And now this.gl. Well, of course it's not with a capital V. Who's the idiot that wrote that with a capital V? Don't answer that question.
I'm sorry. It's my bad.
Vertex enable. Let's try again. Vertex attrib pointer. Is it? Oh, vertex. Why do I keep? Well, I know why I keep doing that. It's because I type text more often than vertex, but it's very annoying. GL is not defined, so that's
okay. Another
of
this.
Yeah, just another one of those things. We have this mismatch.
Oh, and we have a white square.
He's a square. I don't understand it, but it works. Yay! Okay, so those try catches were not working. Or well, no, the try catches weren't working. They were throwing, but the thing is, I need to catch what was thrown.
Yeah.
And so instead of it, ultimately, if there's a throw that happens on init, so I would try catch around this bit, and then return the object that was thrown instead of doing the other thing. So let's test that out. Try catch exception, and then we're going to return the exception, and then I can undo this bit. Well, let's do that, and same thing here. I only did it in 2 spots, right? I think.
Yeah, it was 2 spots.
Yeah. Okay. And then let's go in and break something.
Wait.
We're good at that.
Is that not what... Is that different?
There we go. And then an error occurred compiling the shaders. Error 07 U middle view matrix undeclared identifier. And it happened when we called initialize. So much better than JS interrupt undefined. So
or an alert.
Says you.
Okay, so we can just delete that extra code now, and now we have this pattern for throwing and catching and then returning the appropriate error to the code so that we understand what's going on instead of blundering around for a few minutes. Okay. There we go. And I fixed the thing, right? Hey, John.
Yes.
It's not 10 o'clock yet, and I did the thing that I said that we were going to do.
Is Wes still here? Do we get to do the fun stuff now?
Can you make the ball bounce?
Wes was here for the fun stuff.
I wish I could, but I can't because the position of the square is defined for some strange reason in the init buffers call.
Yeah, another thing I noticed is your shader dependent on that mat4 library too?
No. Mat4 within the shader language is part of the GL.
Okay.
It's the GL shader language, GLSL. So this is another coding language that we're doing in a string, but as you do.
Yeah, as one does.
So I can probably do this now because that's not the problem because this one's running fine and that one's running stuff and things. Okay, so
Wes is still here. He said the fun stuff is a lot.
I think
It's kind of
the-
like
the
I
cake.
think this deserves a commit. You know what I'm saying?
Oh yeah, sure. Let's commit.
Commit
I
that.
am committed.
You said you're in a branch. Is your branch out there?
I will be in a minute. Woo. No.
For anybody
Woo.
following along, here is
Who
a link
I
to
drew
the
a
project.
square. Commit all. Push.
This is the WebGL reboot.
WebGL reboot is now pushed up to the GitHub. It draws a square. So, so the next step that I was gonna play with would actually be moving this init. So it's one thing to init the buffer, right? You can init the buffer at any point. That doesn't even matter, right? And you can do this part, and that's fine too. This bit here, right? These two lines, I believe, are what is actually defining the square and where to place the square. So I would kind of like to convert those into a function, and then we can actually move the square around. And they don't need to be here. Like, it doesn't need to be here at all, I don't think. It just has to happen before each draw, or as you know, on each draw call. But first, we said we were going to refactor this. So if everything was happy in the way I wanted it to be, it would be this dot error, and then it would just be this text. And then we can do that. And then we'll just grab this. Yeah. And then come down to the bottom because it's a helper function and they can just be at the bottom. Error. Message. Return. There. Silly little helper method. Okay. And then we look here, and we grab the thing. There we go. A little bit cleaner. And everything should still function. We'll run it again just to be sure. No, I don't want to be fooled. Don't want that false sense of security. Okay, good.
Should probably also break something.
Yes. How often do you get to say that? Boom, and we get the thing that we want to get. Okay,
Nice.
good.
Nice.
Okay. Tabs versus spaces. Well, I hit the tab button, and it puts in, I think it's a
Spaces.
virtual tab.
Oh.
Yeah, it's a virtual tab, so spaces. I am a fan of the spaces over the tabs, for no real reason. It seems to be the way that a lot of the editors default, and so I just go with it.
You're a man of conviction.
On a lot of things I am. On this, not really.
Yeah, I also go with whatever the default in the editor is and whatever it does. Sure, whatever. I've fought too many things in my life, and the editor is not one that I want to fight.
He's a broken man.
I am.
Okay, so we're going to make a draw square, or well, a draw rectangle. Draw rectangle, and it's going to receive the rectangle address And here's where the fun part happens, because we're going to have to do this. And we're also going to have to make a rectangle class. We'll get to that in a second. So we go to the Init Buffers. We'll see if we can get stuff floating around so that Wesley can be happy. Okay, and we're just going to cut that out. There's no reason to do that there that I can think of. And then we're going to paste it in here. Except we're going to grab those rectangle values similar to this. So this will be top, left, bottom, right. And it won't be color address, it will be rect. Huh?
Wesley's happiness is actually always the most important.
Okay,
Yes.
so I'm not sure. Okay, so negative. If the origin is in the center, and we go -1, 1, and then 1, 1, and then -1, -1. I don't know. We're just going to say top left, top left, and then top right, and then no, that was bottom right, and then top, no, right, top left, no, undo, abort.
Yeah, I think you have it wrong. So
Thanks for the support.
Sorry. No, if the origin is at the center, right?
Yeah.
Well, I guess I don't know if the
So we have x1 which is left. Okay, and then we have x2 which is right. Right? And then we have y1 which is top, and y2 which is bottom.
What I don't understand is normally in mathematical notation we would list x and then y. But
yeah, and I think
we don't always
we are.
do that.
No,
Oh, okay.
I think we are. So
that is the left. That's x1.
this would be left. I'm just going to go down the side because these are all the x's, right? So +1 is going to be right, left,
Correct.
right, and then this would be
Top.
bottom because it's 0 to 1 or -1 to 1, or however you want to do it. It's
0
smaller at the top.
Oh, small as the top. Yeah.
So
okay.
bottom.
Yeah, you're right. Bottom.
Top.
Bottom.
Bottom, top.
Yep.
Left bottom, right top, left bottom, right top. Well, that doesn't make any sense.
No, we did something wrong. Back it up. This
would be yeah, no,
Oh, there we go. No, that's the problem. Okay. Nope. So the top is left, right, and then it is bottom, top. On the Y's are bottom, top.
Cam says there's no way to tell. Okay, so all right. What were you saying, Ash?
What we had is for the X's we had left, right. That was correct. But then we had
it's okay.
It's
yeah,
bottom,
yeah,
top.
Bottom, top.
Yeah.
Okay, so left, right, left, right, and then bottom, bottom, top, top. Yeesh.
Yep.
Okay. All right. So these are floating point values between, well, so -1, 1 is gonna put it kind of in the middle. So it looks like we've got. If I had to guess, I'd say that the screen perspective is from -4 to 4 in all directions.
Sure.
Yes. Down, down, left, right. Whatever it is. A, B, select, start. Actually, so I never did cheat codes on Nintendo, but I did cheat codes on the Game Gear, the Sega Game Gear, and the blood code for Mortal Kombat was 212 down up. So, what? Okay, anyway, so if we call draw rectangle and we pass it a struct that represents a rectangle, top left, bottom right, as floats, then we should be able to absolutely position the square within the bounds of the screen, assuming that based on what it looks like in the demo, that the screen is somewhere between -4 and 4 all the way around. Up, up, down, down, left, right, left, right. Is that... Which one's that one? That's not Metroid, is it?
That's the start of the Konami code. Well, like Contra.
Oh. And then isn't it A-B select start or something like that at some point?
Yeah. Something.
Yeah, I never did that one. And there was like some Double Dragon code as well that I never figured out. Like for invincibility or something. Anyway. Right. So I'm going to we'll start bouncing the square around because the demo hasn't shown me how to use pixels yet. There is another what was it, WebGL fundamentals.
You want to drop the link to that first one in chat here?
No, that's
I
HTML5
can
rocks.
drop that one.
What?
I have it.
Go back. This guy. So there is
That's the
this
demo
one
we're working with.
and this one immediately gets to like if you do an orthographic camera. No. Where is it? Anyway, one of these uses the pixel coordinates in the shaders almost immediately. Yeah, not here, but the next time, I think. Yeah, right here. So this is using coordinate space, or this is using, or I have it backwards. Anyway, this is using pixels instead of the grid, the coordinate grid. But I'm not following these tutorials at the moment. I'm following these because they read a little bit more straightforward and the code is broken out just a little bit better. So I probably will switch over and steal things from that other one in order to get pixel coordinates. But for right now, we're just doing it this way, and I'm just simply manipulating the code that they have presented me with, which is this square in coordinate space.
All right, we are at the top of the hour, so if you want to...
I just want to draw the square somewhere else. I don't even, even
right.
if it's a random place every time. Let's just draw it somewhere not in the center.
All right, chat, hang out. We'll be here for another 45 minutes or so.
Oh, it's not. I mean, it could be. All right, so we've got module, invoke unmarshaled, object, because we don't care. Ooh, hello. Except for it'll be rectangle. Rectangle, and we're just going to say a new rectangle. Not from there. We're going to make our own. Solution Explorer. And we'll come down to Blazor Framework, and we'll say graphics. That's a graphics thing. Add class rectangle, except for it will be a public struct, and it will be public float top. Left, bottom, right. Okay, and then we need a constructor. And the constructor will take float top, float left, float bottom, float right, and then top equals top. Okay, so we got a thing, and then let's come in here and new rectangle, and we're going to say the original coordinates were these here. So left is to top is negative 1.0, left is negative 1.0, right is 1.0, and bottom is 1.0. Float, 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 float. Jeez. Okay. So, hello. So that may or may not work. We'll find out.
If it works, it does the same thing, right?
It'll do the same thing. We just won't have any errors, and then we'll fiddle with the values. I didn't want to change too much at once. Fantastic. I thought we here.
We didn't ever change that, maybe?
I could have sworn we did, but I guess not. Or maybe I Control Z'd and didn't realize it.
Yeah, I don't know.
Okay.
Hey.
So it's drawing the square. It's drawing the square. Yeah. All right. Now we stop because we're going to change the C# code. And then let's, I don't know, -2. Just throw that out there and see what happens. We should get a rectangle now. I think a taller rectangle.
No. That's not at all rectangle. Oh, no.
It is a rectangle. We extended the top up by another, or the bottom.
Gotcha.
It appears we extended the bottom down by another one by adjusting what we thought was the top value. The camera's upside down or something. I don't know. Anyway, we're manipulating values. Ta-da! I'm sorry, Wes. That's the best that John's going to let me do. But we are drawing stuff on the screen, and we are able to manipulate the values that are assigned to those things. So
yeah,
it is progress. And next time we work on this, we'll probably add color and animate something bouncing around the screen.
Yeah,
and change to pixel coordinates.
Yeah, long boolean's waiting for rotation. Yeah, Wes is getting tired. It's past his bedtime. Best time.
Technically, yeah, mine too. But that means that we completed this particular demo, and we can move to the next one. So the next thing is applying color to the vertices. So next time we'll be able to actually do something like that.
Ooh, fancy.
Yeah, I'm actually interested in this per vertex color arrangement that they've got going on. So that'll be interesting and neat. And we might, I know I just said we were going to do animation, but maybe we'll do like some kind of color cycle on the vertices.
Yeah, let's do it.
All right, so with that, we will post a link in chat to Clayton's repo. Give him a star. Follow along on the GitHub. Submit PRs. Fork it. Do more work and show him up.
Don't show
whatever
me
you
up.
want to do.
Come on now.
This has been the Six Figure Developer Channel. We broadcast live the podcast recordings at 6 p.m. Eastern on Mondays. We are here doing the live coding live stream on Wednesdays at 8 p.m. working on personal projects, whether it's Clayton's Blazor Game Engine, John Ash's Lift Fit Log, a fitness tracker in React. One of my projects, either Speaker Meet, a website for speakers, conferences, and user groups, or Triple Derby, an online horse racing simulation game. We would certainly love to have you follow along, subscribe, like, chat, follow us on Twitter, do all the fun stuffs. And then next Tuesday, we will also be hosting the stpete.net meetup at 7 p.m. Eastern, so we'd love to have you on that. With that, we will say goodnight, everybody. We will raid our friend over at JBlow. So hang tight, chat, and follow us over to JBlow's channel.
Good night.
See ya.